Just to give you an introduction about the company itself, because you may not know who Mobiware is and why I'm capable of talking about this topic. So we create IP, intellectual property, and we license to large customers who integrate our IP into SoCs. It could be FPGA, it could be a SoC. We license IPs worldwide, and as I mentioned, we are primarily a high-speed RTL controller IP company, and then we work with third-party SerDes companies, analog mixed-signal companies, who provide the other piece that we complete the solution. So we have PCI Express, RapidIO, we have Ethernet controllers, memory controllers, so all the DDR3, DDR4, LPDDR3, and so on. And we also have higher layer IPs, so things that sit on top of the protocol. So I consider PCIe, RapidIO, they are just general protocols. And on top of it, for example, in the flash storage area, there is NVM Express. So we create IPs that is, first layer is PCIe, the second layer is NVM Express. So we have those IPs as well. We have some error correction like LDPC IP. So primarily we are a technology company, and we create products to license to third parties who create silicon, and whether an FPGA or ASIC. We are in Milpitas, and we have office in India. And this is actually a continuation. For last 15 years I've been in this business. The first venture I started after leaving Cadence was 96 GDA Technologies, and then 2012 we started Mobiware. So it's a continuation of almost the same thing. And the interesting part about that is, if you look at the evolution of these technologies, they're starting with, I think somebody mentioned 1.25 G and 2.5 G type of SerDes. So we have been following the Gen 1, Gen 2, and Gen 3. So Gen 1 probably 2.5 G, Gen 2 is 5 G, Gen 3 is 8 G, 10 G, those kind, and Gen 4 is now 16 and some 25. So we have been from 2000 onwards, we have been part of all these technologies. We had a presentation at DesignCon with Rambus, and as you know, they are one of the pioneers in the high-speed space. So this is a general description of all the things from a high-speed design standpoint. Since the topic was what are the keys to high-speed design, I thought that I will put the full picture. However, I want to say that we are far from solving this problem. We could solve one box out there, and some of the discussions that you heard here, they are solving other things in that. The primary two things, if you look at, one is the pre-silicon space and the post-silicon, and one is the signal integrity related issues in terms of the package design and the signal and power design, and the other one is power related issues in terms of creating the modeling, thermal analysis, and so on. What I am going to talk about is what is on top of those electrical aspects. What I'm showing here is the PCI Express, the layered approach, where we have, after the SerDes, we have the MAC layer, we have the link layer, and we have the transaction layer. So this is true for almost all the protocols out there. And one of the beauty of this is that if you change from going from 2.5G to 5G to 7G and so on, you can actually keep some of the layers the same. You don't need to change every layer every time. So for example, if you go from Gen 3 to Gen 4, you might just change the MAC layer, and all the other things can remain the same. In terms of interconnects, for certain applications, certain interconnects are better. For some of the applications I'm looking at, from a scalable server architecture for data center, for storage, and some of the applications, then I look at what are the low latency, scalability, and power, and then I arrived at a matrix that is comparing RapidIO, InfiniBand, Ethernet, PCIe. So certain applications, certain protocols make sense, certain other things don't make sense. For example, RapidIO has been known to peer-to-peer communication, scalable architecture. It's much better suited than many of the other applications. From a digital standpoint, from a standards standpoint, we are still at 25. Typically, we use the 28G SerDes for the 25G standard applications. In this case, PCI Express and Ethernet and RapidIO all moving towards 25. So the main thing I want to talk about is you need to have the digital piece and the analog piece for the whole thing to work. And one of the big challenges, there is not enough specifications between the digital aspects and the analog aspects. The analog companies create the best analog design, the digital companies create the best digital design. End of the day, you get both these things together, you have to put it together, and you need to make sure it works. And sometimes it doesn't work. But those are some of the challenges that I have come across working with customers. The other one is in terms of taking the design from one technology to another technology for different applications, from whether it's a printer application versus server application. It could be the same protocol, but how do you move from one to another? The other one is verifying the design from, there are third-party verification tools available. Some of them, they have their own issues, so we have to figure out how to do it. And finally, the post-silicon validation and certification. So this is a big challenge in our space. Take your PCIe or Ethernet or any of them, take to a lab and get it certified. They keep changing the test suite. Like every time you go there, they have one more test suite out there. If to pass that is a big challenge. Sometimes it's a big, like I call it, almost like a lottery. So, okay, that's all.